Today, today we shall take a look at these two physics questions. The first one is explain the statement that the acceleration due to free fall on the equator is 9.78 meters per second squared. The second question, we have to calculate the force of attraction between a star of mass 2.00 into 10 to the power of 30 kilograms and the Earth, assuming the star is located at this distance from the Earth. So the mass of the Earth is 5.98 into 10 to the power of 24 kilograms. Acceleration due to free fall is 10 meters per second squared. Newton's constant or universal gravitational constant 6.67 into 10 to the power of negative 11 Newton meter squared per kilogram squared. Now, the first question is very simple. Now, the answer to that problem is this, the solution. The statement means that on the equator, the force of gravity acting on an object causes its velocity to increase at a rate of 9.78 meters per second. So that's the meaning of that statement. Now, in our previous video on Newton's law of universal gravitation, we stated the formula, and that formula was actually derived, and we stated some of the factors that influences the value of acceleration due to free fall or acceleration due to gravity at every location on the surface of the Earth. If you've not watched that video, please do well to watch it so that you can gain more insight. Now, if we take a look at question number 2, when I saw this question, I smiled. Now, this star is actually the sun. Now, this distance you are seeing here is the mean distance of the Earth to the sun. Folks, because the Earth is elliptical, you need to watch our first video on Newton's law of universal gravitation. All these things were stated clearly there. We indeed stated the Earth is not a sphere, but it is elliptical. Something like an egg. So it therefore means that there are times when the Earth is closest to the sun, and there are times when the Earth is farthest from the sun. Now, the time where the Earth is closest to the sun is what they call perihelion. And for this very year, it was January 2nd, 2024. And at that very time, the distance of the Earth to the sun is 147 million kilometers. Somewhere in July, specifically July 5th this year, the Earth will be at its aphelion. July 5th. And it will be farthest away from the sun, and the distance would be 153 million kilometers. So this for the sake of those who are very vast in geography. Now, the reason I brought this insight to this problem is that this distance you are seeing here is the mean distance of the Earth to the Sun. Common sense. If we add 153 plus 147, that would be 300. And the average of 300, which is 300 divided by 2, is 150. So that's the value you are seeing here. It's just for the sake of emphasis. So to solve this question, we are going to use Newton's law of universal gravitation. Since we are dealing with a star and the Earth, we shall write the formula like this. Force equal to gravitational constant, the mass of the star, the mass of the Earth, divided by the distance between them squared. Now from the question, the distance between the Earth and the Sun, which is the mean or average distance, please don't forget that. So that distance is 1.5 times 10 to the power of 8 kilometers. It's not an SI unit. The SI unit of length is meters. So if I multiply this value by 1000, that's going to give me 1.5 times 10 to the power of 11 meters. So this is the value of the distance we are going to use for our computation. That being said, we substitute the given variables into this formula. We have F equal to 6.67 times 10 to the power of minus 11 multiply mass of the Sun 2.00, limit of 2.00, 2 times 10 to the power of 30 multiply 5.98 times 10 to the power of 24, all divided by 1.5 times 10 to the power of 11 all squared. That's what we have. Now this is the work of a calculator. The best I can do to let the calculator breathe and not suffocate it, I can actually use this to multiply this. So that will now be F equal to 2 times 4, 2 times 7, 14, 2 times 6, 12 plus 1, 13, 2 times 6, 12, 13. So if I add this to this, that should be 30 minus 11, which is 19, times 5.98 times 10 to the power of 24. If I square the denominator, that will give me 2.25 times 10 to the power of 22. So if you impute these values very well in your calculator, I'm going to have this force to be 3.54 approximately to 3 significant figures times 10 to the power of 22 newtons. Now, to you, this force is quite very large. Yes, indeed. But the fact is this, the mass of the Sun and that of the Earth is quite very enormous. That's the reason why you are seeing something large as a force. But in our next video, we shall delve into Einstein's theory of general relativity, where we need to see the work of Einstein in trying to modify Newton's law of universal gravitation. Before then, stay blessed. God bless you.